Hi, welcome to Java Learning Center. My name is Srinivas Dande. I am your Hadoop faculty. Well, in today's session, we'll see importance of Hadoop, why every company is trying to adapt Hadoop, what challenges enterprises are facing currently, and how Hadoop is going to provide the solution for the challenges faced by the enterprises. That is the agenda of today's session. So after the session, I will give you the time to ask your queries, whatever you have. Right. So first we'll start with big data. Big data, big data, big data. So everybody is talking about big data. What is big data? What is big data? It is simply, if you have a large amount of data, that they are calling as a big data. What exactly a large amount of data? Why today only we are calling big data? Why it was not there 10 years back? Why it was not there 20 years back? You have data. Data is there everywhere. Data is there everywhere. And data we are processing every time. For processing the data only, we are developing IT systems. So whatever the software we are implementing is mainly for processing the enterprise data. So data is there in 1970, data is there in 1980, data is there in 1990, 2000, 2010, now 2015. So data is there, processing is common. What changes happened? So why today we are highlighting explicitly big data, lot of challenges, we need something new. Now, so I think you are seeing a small diagram on the screen. What happens in an internet minute? In 1 minute, what is happening in the internet? I think some of these terms you are well known, very comfortable to you. I won't find any guy among you who don't know YouTube, who don't know Google, who don't know Facebook, Twitter, LinkedIn, Amazon, right? So every day your life starts with Google. So can I identify any person who don't know Google? Impossible. Simply, if you want to order some pizza, what you do first? Open Google and pizza corner, any pizza centers, Mathikere, pizza centers, Bangalore, near to your location. Pizza centers, Marathalli, pizza centers, BTM layout, the locations near to you. So how a human being is depending on a Google nowadays for any small task. You want to purchase a mobile, search the Google. You want to purchase a book, search the Google. Everything. And you will feel very happy to connect to your friends through a Facebook or a Twitter or LinkedIn, right? So whenever you open a Facebook, you feel happy. You're going to see the message posted by your friend, and you're going to post something new, what is happening in your life. So you are enjoying a lot of excitement moments every day. So you are happy. You are happy to post the message in the Facebook, and you are happy to tweet in the Twitter. You are happy to see some person in the LinkedIn. You are happy to see a lot of videos in the YouTube. You are happy to search a lot of things, whatever you want in the Google. Everything is fine. But behind the scenes, what is happening? So if you observe this diagram, YouTube, 30 hours of video uploaded every minute on the YouTube. 30 hours of video uploaded every minute on the YouTube. Google, everybody searching for anything. 2 millions of search queries entered by the users every minute. Different things. You say pizza corners in my area, and nowadays you no need to say pizza corners in particular location. Pizza corners, pizza centers, Java learning, Java training centers, Hadoop institutes, some other, whatever you want to search. Just you are giving a query, search query. 2 million search queries entered by the users. So how Google is managing all this internally? You are entering simply, but what Google is doing behind this? And if you observe when you are entering this, it will show you some recommendations down. Means somewhere Google is saving all these search queries, storing all the search queries, 2 million search queries entered by the users are persisted somewhere, grouping all that. Whenever you are trying to search something, it is trying to find related queries already entered by some user somewhere. If entered means how is the frequency. So depending on the search, so how the people are searching, what item is searched more in the internet. Means Google is identifying customers' trends. How it is identifying customer trends? So what is the common search query given by users? Means which query has searched more times. It is storing that. Means so whatever the search queries Google has entered, user has entered in the Google, it is storing somewhere, managing all that. Next, going to Facebook. 6 million Facebook views per minute. And coming to the posts, a lot of posts. Similarly, Twitter. Similarly, Flickr. Maybe Flickr not very much used, I think, in India, but it is there in use. But LinkedIn. Mobile apps. Nowadays, you have a smartphones. Lot of smartphones. How many? You can say billions of smartphones across the world. So roughly the statistics says 7 billion smartphones, and every day new mobile applications coming, lot of downloads happening. So if you see this kind of so many, just we are seeing the cases which are a bit comfortable to us. Like every enterprise, every user nowadays connected to internet, connected to mobile, lot of data has generated every second, every minute for every enterprise. So not only this, not only the user what entering in the Google, not only the videos what a user has uploaded in the YouTube, not only the posts, tweets. There are a lot of networked sensors running. Nowadays, you can see small statistics given there. Today, networked devices, sensors, what is the global population? Global population, number of networked sensors are equivalent to the global population. By end of 2015, you can expect that by end of 2015 you can expect that number of networked sensors double to the global population. So every networked sensor continuously generates large amount of data. So one side users are generating across the globe, one side devices, mobile phones. So you are getting lot of amount of data every day, every minute, every second. This is what is known as big data. This is what is known as big data. So now we are saying lot of data. How much data it is? Whether it is 100 MB? No. 100 GB? No. 100 TB? Terabyte? No. 100 PB? Petabyte? So you know some, I think, right? I'll show you the remaining metrics. So I think you are comfortable with GB. 1 GB. So hardly, if you see 1990, we have the hard disk capacity around 1 GB. So one hard disk, one disk capability is 1 GB. But nowadays you have 100 GB is there, 500 GB is there. Next we reached terabyte also. So I am calling this, now you have maybe nowadays 1-2 terabytes there. So what about I want to store 100 terabyte of data. I want to store 100 terabytes of data. Maybe more than that. Say you have PB, petabytes. This TB is the terabyte. So 1 terabyte equals to 1024 gigabytes GB. Similarly, 1 petabyte equals to 1024 TB, terabytes. So next you have hexabytes. Same 1024 petabytes. So you call as EB, 1 EB, 1 ZB, zettabytes, yottabytes, YB. So where we are now? So we are at still the disk capabilities are 1 terabyte or 2 terabytes. So what about my enterprise scenario? I have 100 terabyte of data, or maybe I have 1 petabyte of data which is equivalent to 1024 terabytes. I have 1 hexabyte of data. This is a big data. So large amount of data has been generated nowadays. Large amount of data has been generated nowadays from various sources for every minute, every second. So now storage capabilities, we have some storage capabilities. So beyond the storage capabilities, we are getting the data now. So one statistics says that, so every day 3 hexabytes of data is being generated. Every day 3 hexabytes of data. Hexabytes, where you are? Here. How much hexabyte means? 1024 petabytes into 1024 terabytes means 1024 or 24 you leave for some time, 1000 into 1000 terabytes. So how much it is? 6 means 10 lakhs terabytes of data. 10 lakhs terabytes of data is being generated every day from various sources. Source may be the mobile, source may be the internet from any of these, source may be a networked sensor, network devices, maybe the satellites. Satellite also I am calling under network device. Right? So 1 lakh terabytes. I am using this converted terabyte because this you are bit comfortable to pronounce. Maybe you are using in your daily life, maybe MB you are comfortable to use, you have used I think, and you have used GB, you have used TB, terabytes. Next, you didn't use much in common life because you don't have the storage capabilities for hexabyte, you don't have the storage capabilities for petabyte, you don't have for zettabyte, right? So usage of that is commonly less in the normal your regular life. So what is big data? Big data. Everybody is talking about big data. What is big data? So this much nowadays 1 lakh terabytes of data is being generated. 1 lakh terabytes of data is being generated from various sources every day. This is a big data. So what to do with this data? What to do with this data? Okay, it is generating lot of things. So what I can do in this 1 lakh terabytes, maybe my enterprise is generating some 1 terabyte for example. So every day my enterprise also generating 1 terabyte of data. So in that, why to store all the data? What I want to do is, so whatever 1 terabyte of data is coming to my application, my system generating or some other whatever the data sources I have for my organization, through all these sources I am getting 1 terabyte of data. So I don't want to store all this. Why to 1 terabyte means say I have one hard disk of 1 terabyte. Every day one hard disk I have to maintain to store all the 1 terabyte, one hard disk. Next day again another disk. So I have to maintain one data center with lot of racks. So if I maintain one data center, rack 1, this is rack 1, you call rack 1. In this I can keep disk 1, disk 2, disk 3, disk 4. say assume that in this I am keeping 4, again 4, like this I can keep 30 disks on this rack 1. Per day I have to maintain 1 disk for storing 1 terabyte. Per month 30 disks required where I have to maintain 1 rack. Per year 12 racks. Fine. But enterprise, whether enterprise is capable to store all this or not, maintaining a data center in their own is definitely a complicated task for every enterprise. So they have to use some other data center. Increasing the racks in the data center is an expensive. Whether enterprise can bear the expense. First question, cost matters. Second question, why this enterprise is storing all this data? Why it is required to store all data generated from various sources at one place? Why it is required? So as of analysis is generating 1 lakh terabyte of data, and it keeps growing. It keeps growing. It keeps growing. Right. Now, what enterprises are doing actually? What enterprise needs? So enterprises has to analyze this data. Why they are showing interest to keep all the data somewhere safely is they want to analyze this data. What they want to analyze is a second question. We'll come back to that later. So now we understand what is big data. Big data is a large amount of, or I can use the term massive data has generated, or massive data is being generated from various sources and it keeps growing. What to do with this data? So here 3 important terms to understand. One is V. Second is V. Third is V. V. Volume, variety, velocity. So if you want to understand the big data definition itself includes these 3 terms: volume, variety and velocity. These 3 are closely related to your big data definition. We'll see how much data. Volume represents the size. How much data is being generated? 1 hexabyte. 1 hexabyte, or 3, what we are seeing about 3 exabytes. So massive data has generated per day. So large amount of data has generated today, for example. Next, variety. So what volume represents? Volume represents the size of the data is being generated nowadays from various sources. So how much? This much. This much is very big. Next, variety. This is type of data. Type, it represents type. What type of data generated? what type of data generated from various sources. So in the first case, we have seen that 3 exabytes of data is being generated. What type it is? And can I store all these 3 exabytes of data in the relational database? If I want to store all these in the relational database, then I must have, the data must be a structured data. Means you want to store some data in the RDBMS. I think all of you are comfortable with RDBMS like Oracle, MySQL, Sybase, DB2, etc. So this data I want to store in the RDBMS. Anyway, you know how to use RDBMS, how to store, how to retrieve, how to do operations on that. But here is the problem. This data is the data generated every day. 80% of data is unstructured. Only 20% is structured data. So what is the meaning of unstructured data and structured data? So I can say this 20% of structured data can be stored in the RDBMS. So when you want to store the data in the RDBMS, what is required? First you must define a schema. What is a schema? That you are calling normally as a table, right? Table structure call as a schema. If you want to store the data, first you have to create a table. Can I store the data in the RDBMS without a table? No, impossible. When you are creating a table, you are specifying the schema. So this particular value, data type integer, this is character, this is float, this is this, this is that. So whatever the schema you specified while you creating a table, you have to bind for that. So the data which you are storing into the RDBMS conforms to the RDBMS schema. So the data generated nowadays, 20% only structured, means 20% only can be molded to RDBMS schema. Means the data which is a structure, which is a schema, well-defined schema, fixed schema, is a structured data that can be molded to RDBMS. What about 80% of data which is unstructured? Maybe in this 80% unstructured, some you can say as a semi-structured also. Semi-structured. We'll see that. Main category is unstructured, structured. 80% of the data that is being generated nowadays from various sources is unstructured. Means no structure, no schema, no rules. What is unstructured? It may be a simple text data, it may be an image, it may be a video file, audio file, it may be a PDF. It is different. If you go to the YouTube, everything is a video. Facebook, you have the text messages, tweets you have. Even in Facebook, you can go for images, lot of images you are uploading every day. And you can upload videos also. Some images you can upload, text you are making. So, data in the different formats. Here variety represents difference, type of data. Different types of data is being generated. Large amount is one, volume. Data generated from various sources is a massive amount. That represents a volume. And this data generated is in different formats. How to mold all this into the RDBMS structure is a challenge. And third is velocity. Velocity, what velocity? Speed. How speedily data is coming? So this 3 exabytes is not for 5 years or 10 years, not for a year. One day, how fastly data is being generated. Per second it is generating terabytes of data. Per second it is generating terabytes of data. So speed. How quickly, how fastly data is being generated. So these 3, or you can say 3 important terms which you need to remember when you define the big data. So what is a big data? Big data is simply a data. Big data is data, but that is high volume, high variety, high velocity. The data that is being generated from various sources is high volume, high variety, high velocity. That much of data, a massive amount of data is being generated across the globe from various sources. That is what is known as big data. That the data is a big data. But how fastly it is coming and how different formats it is generating and how large it is generating. 3 things to understand. Okay. So what to do now? We can't stop this, right? Can we stop? So this is a problem. Big data is a problem now. Big data is a problem. So what to do with this big data now? One simple option is stop generating this big data. Disconnect all the network sensors. Stop YouTube. Stop this Facebook, Twitter, Google. No Google, nothing. If you want to buy the book like our old when you are in schooling, so go to the bookstop, and if you want to buy a mobile, go to search the mobile shop, manually go. If you want to buy anything, there are a lot of shops, manually go and buy. This all simple way. Now data generation, sources you are stopping. So data will not come. You can reverse the things. So you can go back to 1970. So if you see 1970, we have small amount of data. Easily you can process the small amount of data. So what changes happen now? From that day to this date, that year to this year, data generation has increased. How big it is? This shows a high volume, high variety and high velocity, high speed generation. Different types of data coming. Some is uploading video clips, some audio, some text files, some PDF, some Word, some Excel, some web forms. Web forms normally the registration, login, this such. These are all normally leads to the RDBMS storage. Volume, lot of zettabytes of data, exabytes of data, yottabytes of data. So now what to do? We can't change, we can't reverse the case, right? We can't stop generating the sources. That is not an intelligent task. It has to generate. And that generated data has to be analyzed. Has to be analyzed. A new term you're seeing. Analyze, you know. So, big data, I have a big data. So what is big data you have seen? High volume, high variety, high velocity data is the big data. So too much of data, too much speed and too many different types is being generated. This big data you have now. So what do you want to do now? So what I want is, I need a mechanism. I want to store this all the data. I don't want to go for a data summarization. So you have nowadays data warehousing products. We'll come back to this. Data warehousing is there. So the main data warehousing goal is archive your data into the warehouse and use that for the future analysis. That is an option. So first what I want to do is, I want to manage the big data. Manage the big data means two terms, store and access. So whatever different types I am getting, different types of data with large quantity of data is coming with high speed, I want to store somewhere. So some storage capabilities I want. Second, I want to analyze this big data. That is what big data analytics. I want to analyze the big data. Okay, you can understand you want to store the data because data is very important. Without data, your enterprise cannot do anything. So it is a meaning. Yes, whatever data your enterprise is generating, you want to store that. Later you want to access it. So it is good. Now why you want to analyze that? What do you want to analyze? Say your, for example, you are doing some online shopping. So a lot of customers coming, they are purchasing items, they are purchasing some whatever available on, so you can take a Flipkart an example. So all variety of items are available on e-store. So you can go just purchase. Whenever you are giving the amount, they are delivering your items, your data will be stored in that. You are purchasing so many things, you are placing so many orders, right? Then order data you store. Whoever customers coming to Flipkart, they are, if they want to, they are seeing the items available. If they want to, they are purchasing by placing the order, by paying the money through online, credit card or something. Then Flipkart is delivering the items to customer. Over. Now all these customers' data has to be stored. All these orders placed by the customers has to be stored. So Flipkart has to maintain what items are there in the, what items it has to maintain. Next, what customers coming it has to maintain, and what orders placed by them it has to maintain. Well, up to that. What extra, why Flipkart has to analyze? What analysis Flipkart has to do? That is very important. So I want to analyze the big data to find the customer trends. Customer trends are changing. Customer trends, I want to predict. You can use the term predict. I want to predict the customer trends. What is the taste of a customer? What is the taste of a customer? If you see Amazon minute per minute, $83,000 sales happening per minute. Per minute is all online. $1,000 of sales happening on Amazon shopping per minute. So how much per hour, per day, per month? So do you know what Amazon is doing? This is what Amazon is identifying the customer taste. Suppose now your taste, now today you want a mobile, later you are changing to a tab, after that you don't want tab, you are coming back to this. That's depending on your taste, your mind, right? So what is this analysis actually? So one, the real life scenario which is already implemented, you can see that through Amazon. So if you search for some item, for example, if you search for Hadoop, I want to purchase a book, Hadoop book. So down you can see recommended books or books related to Hadoop. They will show you Pig, Hive book, a book in Impala, a book in something, a book in Spark, book in HBase. Who asked all this? Even assume you don't know what is pig. You know the animal pig. You know why pig is related to Hadoop. What is Hive? You don't know what is Impala. You don't know what is Spark. You don't know what is HBase. You don't know what is MongoDB. You have just your friend told that hey, in my company a lot of jobs are there in Hadoop. You better I am reading Hadoop. So you also read. So with enthusiasm, okay, maybe some new thing is coming up where more job opportunities, more salaries. So I'll read Hadoop. You know the term Hadoop. You know the term Hadoop, and when you search the Hadoop, they're showing these are the recommendations. How they know that? Means they already analyzed the existing data, existing customers. Previously, whoever visited Amazon or whoever visited some other websites, whoever seen the Hadoop books, also seen Pig books, also seen Hive books, also seen Impala books. That pattern, that recommendation pattern, they already remembered. Means when you are searching something, simply there, whatever, if you search something, they are not going to database, get it to search whether it is matching or not. If matching, get it and display. They are not doing that. In between, they are storing that. This search query, how many times? Next, increase, number of times. And matching, whoever coming for Android, searching for Android, what else they are searching? Who are coming for Spring, what else? Or you want to go to Delhi. You want to go to Delhi. So you are booking the flights. There also you can see, you book hotels, you book car, some other places at Delhi to view. Means, so whenever you are flying, you need definitely a hotel there to stay. Maybe you need a car to move, to drop you at a hotel from airport. So that recommendations means the previous customers, whoever booked the flights, after booking the flights or before that, they have searched for car also, booked it, and they have searched for hotel also, booked, and flight tickets booked. So that is the customer trend. So that, and even if you go to Amazon, if you are buying any items for your kids, if you are purchasing some item for a kid, it shows that these also recommended for your kid, related items. So normally when you go to buy something for the kid, So you can see that, okay, what it is, it seems different. Okay, go and click. We don't know that. So something I want to buy for my kid. So I searched that. That is shown, displayed. I am seeing that details. Okay, how much is the cost, what it is, features, that I am seeing. And along with that, some other products information also shown related to this. So what I'll do, I'll see what is this. Okay, it seems good. I'll buy this also for my kid. I'll see that. Another came. Okay, this also good. Or if I don't want, I'll ignore. But I don't know the items, some other items available. I want to go for one. I'm going to find something new there. If they're not showing that, how can I find some item is there? That is predicting the customer taste, trends. So in this competitive world, every enterprise has to win. Every enterprise wants to grow, right? Every enterprise will have challenges, a lot of risk management. So enterprise has to predict the customer taste, challenges coming, risk assessment, how they will do all this. That is with analysis. So what I want now, I have a lot of big data. I want to manage it, and I want somebody to manage this, and I want some help from somebody to analyze the customer trends, maybe analyzing my organization risk management, risk, and future. I want to provide some more products. So how to find whether these products, what kind of, after 5 years, what will be the taste of the customers? How, suppose after 5 years, what will be the taste of the customers? How that will be identified? A small case, for example, some customers are coming to Amazon and searching for something, searching for some item is not available. Say 1% only doing or 2% only doing. So some 1 to 2% of the customers are coming and searching for a product, some item which is not there in the Amazon. So what Amazon has to do? It has to store the details. Okay, this new item has been searched, so we have to launch this. So the taste of some customers, they want some item, they don't know whether it is available or not. So you are searching. Say for example, one small case, I want a mobile with some particular feature. Maybe a lot of mobile phones are there. How can I go now? So I want a particular feature on the mobile. Say as per your own taste, you want a particular feature on that. So how you will find it? So you are searching. So mobile phone with this feature. That feature, everywhere it is showing that feature, not there. So what that feature has to be stored somewhere, and that has to be analyzed. Okay, the particular feature has been searched for by some customers. So this feature may be the future outcome. It has to come out in the future. So then that's what analyzing the trends. So that if the companies or enterprises are analyzing customer trends, they can grow a bigger. So what we understand as of now, we know what is big data, how it is coming, where it is coming, how speedily it is coming, and what to do with the big data. Two things to do. I want to manage it safely. Safely is one, and I want to access it very, very fastly also. quickly. If you store data, you want to access it very fastly. How fastly? For example, you know that say you have say one hard disk you have whose size is 1 terabyte. 1 terabyte of data is available in one disk. So disk size is 1 TB, full of data is there. I want to move that to other place. So how much time it takes to move or copy? I want to copy this. I want to copy this 1 terabyte of data into another disk. Can you tell me how much time it takes to copy 1 terabyte of data from one disk to another disk? First of all, how to calculate that? How you can tell 1 terabyte? Or you can say that, you can answer it, I did not see 1 terabyte of hard disk till now. I did not try to copy. So how can I tell how much time? If I buy one hard disk, 1 terabyte, 2 terabytes, one with full of data, if I move that, then I can identify how quickly it is fasting, how much time it is taking. That you need to purchase 2 hard disks of 1 terabyte and 1 terabyte and see that practically. Because there is a data transfer rate. When you're copying the data, you have the transfer rate. Data transfer rate is there. This is another biggest challenge for data manipulation. Data storage capabilities increase tremendously. You have 1 terabyte of data, disks are there, but transfer rate is not improved over the years that much. So hardly nowadays you have 100 MB of transfer rate, 100 MB per second. 100 MB per second. So how much time it takes? How much time it takes to transfer 1 terabyte? In 1 terabyte, how many MBs are there? You have to calculate. Say roughly around 20 minutes. It's not exact figure, I didn't calculate it, just assuming. But around that only, around 20 minutes. Right. So 20 minutes it takes to copy 1 terabyte of data from one disk to another disk, one place to another place. 20 minutes. Now, if I have 100 terabytes, 1000 terabytes going to 1 petabyte of data. I have 1 petabyte of data, means 1024, 1000 roughly, hours, it goes to hours now. I don't want to do my processing that much time. I want to do quickly, at least in minutes, seconds, minutes. But it is, if I have 1 petabyte also, it is taking hours. Hours of time I don't want to spend. It is an expensive task. The cost matters. So I want to analyze. So I want to analyze the big data. Fine. I want to analyze the big data. Fine. I want to analyze the big data to predict the customer trends. Yeah. And I want to do this analysis in a cost-effective manner. Cost-effective. I don't want to spend again a lot of time and resources on that. Days analysis I don't want. I want to do in a cost-effective manner. So, what we have discussed as of now. So, how big data has been generated with a high volume, high variety and high velocity. Now, how to manage it, how to process that, analyze that, in a cost effective manner for identifying or predicting the customer future trends and outcomes. This is what I want to do. Fine. So you understand what is big data? What do you want to do with that? Okay. So now, if anybody is there now to help this, anybody is there now to help this, means any technology available, any system available, any software available, who is there to answer this problem? What I want to do, you got it right. I have a big data. So three things I'll summarize now. One, I have a big data. Two, I want to manage that. Three, I want to analyze my big data for predicting the customer trends and outcomes in a cost effective manner. Now, who is there to help me to do this task? Who is there to help me to do this task? Okay. First we will analyze what are the solutions available currently for this. One option you have, data summarization with data warehouse products. Data warehouse products. What is this? Is a very critical algorithm in the data warehousing products. Data summarization is a critical algorithm in data warehouse products. What is data summarization? Okay, means I stated my problem, right? What is the problem I stated? The problem I stated is I have a big data. I want to manage this. I want to analyze this for in a cost-effective manner for designing the recommendation patterns. That is what I used previously for predicting the customer trends. By predicting the customer taste, I want to design the recommendation patterns. Maybe for risk assessment. So don't do this, do this. And also for customers, for organization perspective, risk analysis, identifying the future, how it grows, how it has to grow, what are the challenges on the way. And for customers, when you are buying this, you also try to buy this. When you are buying this, you also try to purchase this, providing the recommendations. I want to design the recommendation patterns. Like analysis can be done in many ways, depending on the domain. So if bank customers, different recommendation patterns has to be designed. E-commerce products, different patterns. So that depending on the domain, that we'll see at some point what are the enterprises we have, various enterprises, what kind of real life use cases, what a company has to do, this kind of domain, say telecom domain, how they want to analyze, why telecom domain products data has to be analyzed, how that has to be analyzed, that domain wise we'll analyze in a different session. Fine. Now I stated a problem clearly. What is my problem? I have a big data, I want to manage it efficiently, I want to analyze that in a cost effective manner for predicting the customer trends, for risk assessment, and for designing the recommendation patterns for growing my business. Okay, then one guy came that told that, okay, you go for data warehouse. Okay, one solution I got. This is S1, solution 1. In the data warehousing, what used to be done is data will be summarized by discarding the details. Means the full data cannot be stored in the data warehouse. Full data means if you have 1 lakh records in an intelligent manner, you have to summarize that. Means from that important data you take, that only store in the data warehouse for the future analysis by deleting the extra details. So one, summarize the data and discard the details. All the details, the big data cannot be stored in the data warehouse. Only summarize important what you want to analyze. For your analysis, whatever enough data, some you take that, full data, other extra unnecessary you remove and archive that and store in the data warehouse. Store in data warehouse. Fine, okay, this solution I am doing now. But here the complexity for my organization is maintaining the data warehousing products is very expensive. Purchasing the data warehousing products is expensive, and configuring that, maintaining that, mastering the technology, data warehousing technology, getting the people, resources, cost, software, maintenance is very, very expensive. And also ETL jobs. This data warehousing is a term where you are going to commonly use in the data warehousing. ETL, extract, transform and load jobs takes more time. Actually the data warehousing is mainly for the analysis purpose, mainly for batch processing. Okay, taking more amount of time, more amount of cost, because data warehousing products, technology, maintenance, configuration is very expensive, resources expensive. So that much of budget is not there in my organization, so I am not going for this. Means data warehousing is already there. Data warehousing is already there. Lot of tools are there, lot of products are there. More companies are using this by spending lot of money. Very expensive, because there is no way for the organizations as of now. If they want to analyze, they have to go for data warehousing. They are doing that. It's an expense. Okay, that much of budget is not there in my company. I am not going for this. Second solution, go for distributed systems. Okay, this seems somewhat good. Means if you have a large amount of data, you store the data across multiple machines and you access it. Distributed computing also available, is not a new, right? So it's there from years. Distributed computing is there, distributed systems are designed, under implementation, now in production also. So another existing solution is distributed systems. Okay, with the distributed systems, what is happening? So normally with the distributed systems, you have, this is your application. Consider this is your DB, or DB, or instead of DB I can use anything, storage, say storage, some storage, it may be RDBMS, it may be some other storage device, whatever. This is a storage, I am using a storage diagram. Another storage, disk, some storage disk that may be available in some server, some machine. You have a data here, right? So now here I stored 1 terabyte of data. Here I stored 1 terabyte of data. Here I stored 1 terabyte of data. And maybe if you have more, you can have more devices. So when I am processing this, what to do? I want to process. I want to process the data which is the 1 terabyte of data which is in the storage device 1, storage device 2, storage device 3. Right? So when I issue some task, yes, I am telling task 1, analyze, do something, process, some logic, processing logic you don't see, whatever, some logic is there. So I want to do that. So what to do? You have to transfer this 1 GB to this place. Here is your, understand this very, very clearly. PROCESS, processing logic. Your processing logic is here. What is a processing logic? On data you want to do something. Some logic you want to execute. That is a processing logic. What it is depending on the organization, we'll see that next. Now, this processing logic, some code is there. Some code, simply some code you have written for doing something. That code is in this machine at this place. Your data is now 1 terabyte of data in the storage device 1, another 1 terabyte of data is storage device 2, 1 terabyte of data is storage device 3. So this has to move now, 1 terabyte move to this, 1 terabyte move to this, 1 terabyte move to this. You will have now 3 terabyte of data. You run your processing logic on this. What happened? When you run your task, yes, do this task, something, your code gets executed. So it needs now 3 terabytes of data which is available in the 3 different distributed systems. It has to move 1 terabyte of data from storage device 1, 1 terabyte of data from storage device 2, 1 terabyte of data from storage device 3, and it will summarize, it will club all this 3 terabytes of data. It stores in the machine where your processing logic is there. So now how much time it takes to you to move 1 terabyte of data, as we discussed in the previous discussion? 20 minutes around. So 20 minutes this 1 terabyte will move to processing logic. 20 minutes it will take, 20 minutes it will take. Instead of that, assume you have 100 terabyte of data. Say you have a disk capability is there or some other mechanism you are using. In the same, you have multiple disks you are making on the storage device, having multiple disks. One disk capability 1 or 2 terabyte. In this storage device, or it may be considered in your data center terminology, rack 1 is there. This is a rack 2 which is having 100 terabyte of data. This is rack 3 having 100 terabyte of data. So now my processing logic has to run. My processing logic has to run on 300 terabyte of data. So I have to move 100 terabyte of data from storage device 1 to the processing logic machine. I have to move this 100 terabytes of data from storage device 2 to the processing logic machine. I have to move this 100 terabytes of data from storage device 3 to the processing logic, to the machine where the processing logic is running. Computation logic is running, your application logic is running. You can say processing logic, computation logic, application logic, code, what you are writing to perform your task. Right? Or simply you can understand one task that these are all customer records. All customer records. So customer records you stored, total customer records you have in 100 terabytes, 300 terabytes of customer records you have. In that 100 terabytes in one machine, 100 terabytes in another machine, 100 terabytes in another machine. Now you want to search customers to find one particular customer, or you want to sort all the customers. If you want to sort all the customers, all the data is required for you. You have to copy all 300 terabytes of data from 3 different devices to the machine where your application logic is running. What is application logic here? Your sorting algorithm. So the logic, application logic or processing logic or computation logic can be anything which is relevant or related to your enterprise task. So now what is the complexity in this? See, if you have 1 terabyte, it is taking 20 minutes. 100 terabyte, 2000 minutes. 2000 minutes means hours. It will take hours of time. Not okay. Second, so one problem here is moving the data from data storage device to computation logic is a complex task. So I am going to the next screen to make this diagram a bit. This is the complexity where you have to understand much. So here what is happening? This is a machine. This is a machine where you have the computation logic. Right? This is your storage device 1, storage device 2. So here I have it is distributed, right? Data is distributed. 2 machines I am taking. 100 terabytes here, 100 terabytes here. Like you can have multiple storage devices as per the volume of the data what you have. So now your data is here. This is the place where you have data. Data is there. Here is your computation logic. So what you are doing? Moving this 100 terabytes to the computation logic, moving this to this. Here you are preparing your data, this whatever 200 terabytes. Then you are running your computation logic. Results, client is asking, do this, do task, do some task, do some task. Okay. When client asks do some task, then you are running your computation logic. Whatever it is, maybe sorting like one case, anything. So then it starts copying the data from storage device 1 to the computation logic machine, storage device 2 to the computation logic machine, storage device 3 to the computation logic machine. Like how many storage devices you have, how much data you want, now all has to be copied to the machine where your computation logic is running is the biggest problem. It takes time. It takes time. So one challenge what you are observing here is, what's the one challenge you have now? One. So what we are doing here, the problem is we are copying data to computation logic. So that it is taking time. It takes time. So problem here is it takes time. Okay. Other challenges with this. For example, this node is failed. I am talking about distributed systems. Distributed systems means you will have multiple nodes. So each node is one storage device. This is called as a node 1. One storage device is one node. This node is failed or one storage device is failed. Then how? So you cannot, your computation logic will run only on the 100 terabyte of data which is copied from the storage device 1 only. Storage device 2 is not accessible now. Something happened. Because the distributed systems, we cannot predict the problems. Any kind of problem can come at any point of time. So, do you have any solution for whether distributed systems are providing any solution for recovering this data? How? Now, I want to run the computation logic. I want to run the computation logic on the 200 terabytes of data which is available in disk 1 and disk 2. But disk 2 not available now. What to do? Failure of the node. I cannot run the computation logic, one, or I can run the logic only on the first node data, 100 terabytes only I can run the logic. I will give the results back to client. So, I may give the results. If results I am providing, three cases here, see, full results, A, full results. Full results means both the devices happy, both the devices are healthy, and the data from both the devices are copied to the computation logic. Your computation logic has done on the 200 terabytes of data, then full results are given to client. Second case, partial results. Why partial results here? Say second node down, second device down, missing somewhere, not healthy. Then your computation logic is running only on the 100 terabytes of data. The results what you are getting is partial results only, right? Say I want to find, in this customers are there, in these customers I want to find who has purchased some particular item. So I am giving only from the first set, second data set missing. 100 terabytes, one data set, 100 terabytes, another data set. Data set, nothing but set of data, data set, use a term data set. Data set, 100 terabytes, one data set, 100 terabytes, another data set. So if I search these two data sets, I will have full results. If I search only one data set, I am giving partial results only, or maybe no results. We don't know what will have. So second problem what we are getting here is, second problem is partial failures. Failures, how to rectify these failures? In a partial failure case, so you are unable to do your processing logic. You are unable to execute your computation logic correctly or on the complete data sets. That is one problem here. So, what is my question? What is my, why I started? I have a big data. I want to manage it. I want to analyze it for doing something. So I seen data warehousing, okay, not doing well. I came to distributed systems. It also having a lot of issues. Already distributed systems having issues. So where it will rectify for my big data problems. So existing data warehouse products cannot, or existing data warehouse products, data warehouse systems will not provide you the good solution for the big data problems. Second, by seeing this diagram what you are seeing on the screen, distributed systems also, existing distributed systems also not ready to answer your all of the big data problems. So nobody is there now to answer your big data problems. Then one person came called Mr. Hadoop. Mr. Hadoop can answer all this very easily. How it is? So what you want now is, what are the problems we are seeing here? The problems related to the big data. The first idea that changes the entire is, the Mr. Hadoop came now, right? Only Mr. Hadoop can solve your big data problems. There is no other existing systems, software, frameworks, technologies or something to solve your big data problems. Only Hadoop can answer all of the big data problems. So how Hadoop answers all of the problems, we'll see now. So the problems here, first we'll write the problems. The problems are, so what are the problems we are identifying here, at least from this? One is moving the data, copying the data from computation logic. Like this we are doing, right? Like this we are doing. This is reversed actually. Why to move this much terabytes of data from storage device to computation logic? This computation logic is what? A program. Some piece of code you have written to run your task. Computation logic is a simple program, right? So why to move this terabytes of data which is distributed across multiple machines to the computation logic? You take this computation logic only near to the device, near to the storage device. That is the first idea that changes and started giving the problem solutions. Say, I'll give you what I want now. So one, I want to, or I'll take as I want to as a common. Distribute the data. Data distribution is common, right? Because if you have 1 petabyte of data or 1 exabyte of data, you cannot store on the single machine, impossible. So distribute the data across multiple machines. Distribute the data is one requirement what I have. Second, fast processing I want. Fast processing. So in the previous diagram, you are distributing data here. Are you distributing the data into 2 machines, or you may have 1 more machine here? So 3 machines, you are distributing data across 3 machines. So data distribution is there in the existing distributed systems. Data distribution facility is there. You can store across multiple machines. That is there already. But it has some problems like the partial failures, maybe scalability is another thought, you can say scalability. Scalability is another issue. Scale, number of machines. When you have 1,000 number of machines, like this 1,000 number of storage devices you have, if one is missing in between, it is problem. That's what a failure. Right? So, what I want finally, by seeing all these problems, I'm concluding that. So, a lot of already systems are there, so many problems are there. Distribution of data, fast processing required. I don't want to wait 1 hour, 2 hours, 3 hours for. So, in the previous diagram, if you say, how much time it takes to move this 100 terabytes of data to the computation logic? 1 terabyte 20 minutes. 100 terabyte means 2000 minutes. 2000 minutes you have to wait to move the data. Again later logic has to run on that. That much of data I don't want. That much of time I don't want to wait. So quick, fast processing is required. Cost effective way. That is, if you do quickly, it takes less cost. Second, fault tolerant. Fault tolerant means any failures. We have seen the data is distributed across multiple machines. If one machine is failed, it may cause a problem. One machine is failed, my data will go, and I cannot use that data in my current processing. Some issues. So that I don't want. 100% reliability is required, 100% reliability. So fault tolerant system I want. Means node missing also, node missing, data is not there, this kind of answers I don't want to listen. 100% high available, high reliable system without any problems is required for me. Scalability. Large number of systems I want to, 1000 systems I want to connect to store my data. So in 1000 systems distributed, right, 1000 machines you connected as one unit. Your data is distributed across all, right? Your data is case 1. Your data is distributed across 1000 storage devices. If your data is there in the 1000 devices also, you want to do it very fastly and without failures, fault tolerant. And number, if you want extra, easily you want to add it, more number you want. If this is the requirement, currently nobody is there for facility, for high available, high reliable, scalable and quick processing distributed data systems are not there other than Hadoop. So only Mr. Hadoop can answer it. So who has implemented this actually? Just quick, the normal history you can see somewhere. So initially the first idea from the Google, because Google has a lot of search data and they have to create indexes of all this. When you search, they have to prepare some recommendations, suggestions. So Google has the first problem first, and they started developing some solution, and they have developed called GFS. They developed called Google File System. And MapReduce. So currently you don't ask yourself what is MapReduce, what is GFS. This is two things what Google has implemented first. And later they have published one white paper. By describing, at the same time, other companies are suffering from the same problem. Other companies like Yahoo is suffering from the problem. There are so many organizations having big data. This is in the early stages, around 2002, 2003, somewhere. So by this time only, Google has a solution. But Google team, their own team, they have their own products. And other companies in the world are suffering from the same problem. They are searching for the solution, what to do like. So that time Google has their own solution, this, and to help the world, they have published one white paper. So I did already like this. We did GFS, we did MapReduce, something. We are doing well. How this implementation is like this architecture is like this, like some white paper has published. Then makes the life easy. That white paper has implemented as Hadoop by Doug Cutting and team. Right. This normal history, the versions and all common. You have a lot of story. This Doug Cutting is a guy. Later he joined with Yahoo, and with Yahoo he implemented this Hadoop. 80% of work related to Hadoop done at Yahoo only, because this creator of Hadoop called Doug Cutting was at Yahoo. Once the final releases are done, when hitting the wall, when Hadoop is hitting the wall, everybody is thinking and seeing towards Hadoop. Later he joined now with the Cloudera. Hadoop Cloudera. About this, this guy is working with. He initiated his own company called Cloudera by joining hand with others. So fine, this is how it came. The story you can understand where is this kind of stories you can read from internet a lot. But now what we have to see is, I want something like this. How Hadoop is answering all these questions. How Hadoop is answering big data problems. I'll show you in a small diagram. Say I have a file. I have a file called jlc1 dot, simple file you take jlc1 dot txt. I have another file called jlc2 dot txt. Two files I have. Say its size is something. It may be 1 terabyte, or it may be 100 terabytes. One file may be any size. Some big size only, not small. So whatever the size you have, what Hadoop will do first is, it cannot store this big file into one disk, for example. You say this is having 5 terabytes of data. jlc1.txt size is 5 terabytes of data. Can you store this 5 terabytes in one disk? No. Then what you will do? But what Hadoop will do, we'll see now. What Hadoop will do is, whatever the file whatever data you have, maybe in terms of some file representation only, right? Now, it will divide your file data, input file or input data into blocks depending on the size. Suppose it is 100 MB only, it is say 5 MB of file, 5 MB. 5 MB means you can store anywhere. For this, no big mechanism required. Hadoop, you go to Mr. Hadoop only when you have big data, only when you have massive data, large amount of data you have, then only you contact Mr. Hadoop. You have small data, your data is in KB, MB, you don't go for Hadoop. So one you can say this, where Hadoop is not suitable. If you have small amount of data for your organization, please don't contact Mr. Hadoop. Don't use Hadoop. Hadoop is not suitable. It is for large systems, for large data sets, not for small. When your data is growing into the terabytes, petabytes, hexabytes, zettabytes, like then you contact Mr. Hadoop. You have KB, MB, don't go to Hadoop. Say some size is there. So how it represents in the internal is, it divides this into blocks. This I am calling as a block 1, block 2, block 3. Say you consider that depending on the size of this jlc1.txt, this block 1, block 2, block means 3 blocks. It is divided the data file into 3 blocks, called as a block 1, block 2, block 3. And depending on the size of this, assume it has divided into 2 blocks, block 4 and block 5, B5 and B5 and B4. Right? So now, it has to store this data into multiple machines. In terms of Hadoop terminology, it has to store this in the Hadoop cluster. Hadoop cluster. What is Hadoop cluster? Hadoop cluster is nothing but a group of multiple computers connected to work together. So now we are maintaining here small Hadoop cluster, small cluster. Cluster is a normal term. Without Hadoop also you have clustering is there in the previous distributed systems also. Clustering is so grouping some 5 or 10 or 1,000 systems as one unit is a cluster. If you are doing that, especially for the Hadoop, you call that as Hadoop cluster. So I have 5 node cluster. What is a node? One computer in the cluster is called as a node. This is a new terms maybe on the way you can understand. Say now I have 5 node cluster, means 5 nodes I have, This is one node. This is another node. This is another node. This is another node. 5 nodes I am taking. This is my, I am naming this as node A, node B, this is node C, this is node D, this is node E, node E. 5 nodes I have. This 5 nodes is this group, 5 nodes group is called as, this is Hadoop cluster. Hadoop cluster. This is, I can call this as 5 node Hadoop cluster. I have now 5 node Hadoop cluster here. 5. This data has to be distributed. This data jlc1.txt, jlc2.txt may contain terabyte, may contain petabyte, whatever it has to distribute. The data has to be distributed across multiple nodes. And when it is distributing across multiple nodes, it will use the replication factor, replication mechanism. Means whatever data Hadoop is storing internally, it will store that into 3 folds, 3 times. 3 copies it will keep in the 3 nodes. One loss, another it will get it. So what it will do now is, so in terms of Hadoop terminology, these nodes, node A, node B, node C, node D, node E are called as data nodes. Data nodes. Data nodes. Also, these are actually the child nodes. Hadoop architecture is based on is a master slave architecture. Master slave architecture. One master, multiple slaves. These are also you can call as slaves, slave nodes, multiple slaves. Just we have taken a 5 node, 5 slaves. You will have a master now. This is your master. Master node, also called as name node. It is called as name node. So here you are seeing some new terms called name node, data node. Name node, data node. What data node contains? Data node contains mainly data. What name node contains? Data node contains data. Name node contains metadata. What is metadata? Information about your data. What is that? We'll see. So what name node contains? It contains the metadata. So first, whenever you want to store the data into the Hadoop, so first it will see the size of that jlc1.txt size. Depending on the size, it will divide that into blocks. Each block size minimum default, not minimum, default 64 MB. So each block default size, default is 64 MB. I am writing here block size is 64 MB is a default. A recommended factor is 128 MB. So that will have less blocks. Otherwise, so many blocks means it may take time. So 64 MB. Assume maybe this each block size is 64 MB, 64 MB, 64 MB, or maybe if you take 128. If you have 1 GB of 1 GB file, for example, jlc1.txt is 1 GB, then if 128 is the one block size, so how many blocks it will divide? 1024 by 128. That means number of blocks will be divided. So consider something here. 3 blocks. Now, this information, JLC1, 3 blocks, JLC2, 2 blocks only. Another file, JLC3, may have 10 blocks. So each file, how many blocks divided? That meta information will be available in the name node. What name node contains now? It contains here that jlc1.txt, jlc 2.txt. JLC1.txt blocks are 3, B1, B2 and B3, and JLC2 having blocks B4 and 2 only. JLC3 another file, maybe have 10 blocks, maybe 20 blocks. For example, I have 1 GB file. 1 GB file I given. 1 GB means 1024. Each block size 128. So how it makes 1024 by 128, right? So how many it comes? Or you are taking 64 only, size of 64, this, it may come into 8. So 8 blocks has to be divided. If block size is 64 MB, 8 blocks has to be prepared. If block size is 128, it may go for only 4 blocks. So depending on the data of the file, block size maybe 64, maybe 128, default is 64, and you can customize it. If you want more, you can. That's not fixed, you can customize, right? So the number of blocks is depending on the size of the file. We are just considering JLC1 for 3 blocks, JLC2 for 2 blocks. Now when it is storing this, it will use the replication mechanism. Means it will store each block 3 times into 3 nodes for the high availability, reliability. What we need is, we need a fault tolerant system. We need a fault tolerant system. If one node missing, we should not lose the data. If one node missing, I am not ready to lose the data. I am not ready to stop my process also. My process has to continue. My data should be there always, high available, 100% high availability and high reliability I need. That is guaranteed with Hadoop. How it is? See here, you block one, so it keeps the block 1 at 3 places. Block 1 in the node A, anywhere, it will based on the availability. Block 1 here and block 1. Any node available, it will store 3 places. Same block 1, 3 times it is storing, 3 copies. So later whenever it needs, it will contact node A, which is having block 1. If due to any reason node A is failed, no tension, no problem, because the same block is available on node C also. It will go and get from node C and access that. So my work will not be stopped. I am not losing the data. I have another copy in node C. In a worst case, node C also failed. Still I have one more copy of B1 on the node E. So the replication factor is default 3-fold, 3 times. Default block size is 64 or 128. 64 is the default. Recommended is 128. Replication default is 3 times. Block 1 is in node A, 1 copy, node C, another copy, node E, another copy. And this also, I don't want 3 times because my cluster is very reliable. I am using good hardware and all. So I don't want to, I may not get the failures more. So I want 2 copies only. Yes, you can. You want 4 copies, 4 factor, replication factor 4 folds, 4 times you want. Yes, you can change it. It can be customized. Default is 3. So now about block 2. Block 2, three times. Somewhere it is storing. How it is storing, where it is storing, why it is storing in that node only. You should not ask any of these logics to Hadoop. If you ask all this, Hadoop will get angry, because all this low level plumbing work will be done by the Hadoop for you freely. You don't concentrate on any of these. You don't take any tensions about this low level, how many clusters are there, how many blocks it is preparing, where it is storing my blocks, whether it is really storing or not. If a node fails, whether it is going to get from other node or not, you don't worry about this. You give a file, go home. Later, whenever you want, ask, give me jlc1.txt file. It will do something, it will give your file to you. You take and use it. Your file jlc1.txt may be 1 terabyte, 2 terabytes, 100 terabytes, 1 petabyte, whatever the size you have. You give the file to Hadoop. It will divide that into the multiple blocks, keeps that across the network, and whenever you ask, safely it will get it and show it to you. But here just we are taking a small case. So now block 2 is again three times stored. Now where it is storing each block, that information also should be maintained here. That is also very important. See, block 1, block 2, block 3, block 4, and it is storing block 1 at 3 nodes. Where it is? Block 1 available in A node and C node and E node. Block 2 available in B, C, D. Similarly, block 3, just for I am showing like this, block 3, and take block 3 also. So where is block 3 now? A, B, and block 3, 1 copy in A node, 1 copy in B node, 1 copy in C node. 3 copies there. Block 4, say in B, in A node it is there, and D node it is there, and here it is there. So where it is? A, D, E. A, D, E. 5 is in B5, whatever locations, just a small B, C, D, B, C, D, 3. So what name node contains? Name node contains only just meta information, that the file is there, file is there, jlc1.txt, it is having 3 blocks. Information of that is available as in the name node. Metadata is jlc1.txt is divided into 3 blocks. What are the blocks? B1, B2, B3. That information is there. And also, where is B1? B1 is B1, 1 copy in the A node, another copy in the C node, another copy in the, that information is there. Now, see your problems, whether all the problems are solved or not. Whether all the problems what I got previously solved or not, see the problem and answer on this diagram. So first one, distribute the data. I have large amount of data, massive data generated from my organization sources a day, terabytes, petabytes. Can I store that across multiple machines now? I am able to distribute the data across multiple machines using the Hadoop. Yes, you are able to do it. Fast processing, how it is Hadoop brings computation to data. Computation to data, where data is stored. Instead of computation logic is there. Say in this diagram, I'll go to previous diagram. See here, your computation logic is here, right? Now, data, you are moving here, from this third machine, fourth machine. Why to do all this data? Computation only run here, computation logic only run here, computation logic run here, computation logic run here. brings the computation logic nearer to data. Instead of the bulk amount of data moving over the network with the low transfer rate, taking more amount of time, wherever data sits, don't move data, let the data to sit there only. Whatever computation logic you want to run, you run the computation logic in the machine where data resides. That is the biggest change and hits this speediness. So now, fast is okay. Very quickly it gives the results. How it is possible is because of brings the computation to the data. Next, two more to discuss: fault tolerant and scalability. So now here we have taken a 5 node. Data is stored in the node A, data is stored in node B, data is stored in node C, D, E. Whenever you want to process this, whenever you want to analyze this, you no need to move this data from these nodes to some other place. Whatever computation logic you have, you run the logic in this place only. What is node A? Node A is a data node where your data stored. Node B is a data node. Node C is a data node. All these are data nodes where your data stayed. Here only run the computation logic. That is, computation logic is now near to data. Where data is there, your logic you are running there only. You are not moving the data across the network where you are getting the problems. Right? So now very quickly you can do it because you are not transferring any single byte of data also to other machines. Data is there in node A, data in node B. Run the computation logic. Your logic in every node, here only. How many data nodes you have? In every data node you run the logic. Don't move single byte of data also over the network. That makes you a system to respond to your query very, very quickly. So I am getting results very fastly with Hadoop because of this biggest change you observe here. You are not moving the data to the computation logic. Computation logic now you are running in a place where data is there. So no network latency problems, no bandwidth problems. You can do the task very, very quickly. Now node failure case. When node A failed, what happens? Nothing. When node A fails, you are not going to lose any data because the copies of that already available in other nodes. It will use the mechanism called heartbeat mechanism. If node A is not responding within a specified amount of time, immediately it will contact another node where this copy is there. Suppose now it needs block 1. Need to access block 1. It will check block 1 is available in A node. So it contact A node. If A is running, A is healthy running, then it will take that and process. If node A failed, no problem. Already same copy is in node C also. Go to node C, use same block 1 and process it. So no failures now, no data loss, no failures. 100% cluster maintains all of your data, process that. So here two things we have: processing the data is one, storing the data is one. We are storing the data, we are processing the data. Where you are storing the data? You are storing the data in the name node. Where you are processing logic, computation logic, your application logic, where it is? It is also in the same machine called name node. Your data is in the same place. In the same place when you are running your processing logic, application logic or computation logic. That makes you faster. Second, fault tolerance. If one node fails, that won't stop your work because another node is having same data, right? Even the processing logic also will be shared similar. If you see more internal architecture of that and execution flow, you'll get scalability. This Hadoop cluster can easily be changed You can add n number of nodes into that. You can use commodity hardware. The simple hardware you can use, very less expensive hardware. So in order to maintain a complicated servers to maintain this Hadoop cluster, that is another biggest achievement is, whenever, now here I have taken a 5 node cluster. These 5 nodes are the 5 machines, 5 PCs. You can use normal commodity hardware. No need to go for expensive servers, lakhs of rupees servers, not required. Normal hardware, what you are using, you can use as a node in this. That makes you the less expense. So now my data distributed, I am accessing the results very fastly, I am managing all the data safely, no data loss, no failures, I have a big scale. So that is what Hadoop answering all of your problems. Alright, so that's how it is doing all this is, if you understand Hadoop, the basic architecture of this, so it has mainly 2 things to understand. One is HDFS, second is MapReduce. These 2 actually called as Hadoop core components. Hadoop core components. What HDFS will do? What MapReduce will do? What actually we want to do? We want to store, we want to process the data. We want to process the data, we want to store the data. You want to store the data, then HDFS will help you. This is mainly for store the data. Storage information, how it is storing, how to store, how to divide blocks, how to again club this, all the storage implementations maintained by the HDFS. So if storage data storage tasks will be done by HDFS, and MapReduce is for process the data. So 2 major tasks you want to do. You want to store that large amount of data, a massive amount of redundant data, redundant massive storage is HDFS. So dividing into blocks and making 3-factor, all that storage information, HDFS. After that, processing, you want to process it, analyze it, do something, whatever processing, use the MapReduce. These are the 2 core components of. In addition to that, for simplification, there are a lot of tools coming up called as ecosystem projects. Just I'll list a very important over here. You have Hive, a pig, Flume. There are some Impala, so many. These are called as ecosystem projects. These are all ecosystem projects, are nothing but simplification. Instead of you doing a lot of tasks, they are providing a simplified options, right? So that's about what we have to learn mainly in Hadoop is the core components you have to master. HDFS, how it is storing, how it is retrieving, MapReduce, how to write your MapReduce logic to process data. You want to process data in different ways, that depending on your analysis, how you want to analyze. The analysis trends depending on your organization requirements. So you need to write different processing logics, that how to write MapReduce programs, then how to use the ecosystem tools like Hive, Pig, Flume. That's what. So that's about today's session, introduction session. Right. Thank you.